right, and time for day 3 in chapter 1, where we get to talk about exponents that are really bad. No, that was horrible. And we just talk about negative exponents. Yeah, that was also horrible. But we do talk about negative exponents. With me, Mr. Hain. All right, enough with the jokes. Let's get to the essential question. What do negative exponents actually mean? What do they mean? We're going to address that question in today's video and exploration of negative exponents. Mathematical practice 1, persevere in problem solving. Some of these can be weird. Let's dive right in. Okay, so like if you have my notes or you've downloaded them from somewhere or something like that, awesome, because there's a lot of charting. So for those of you who don't, I would pause the video right now, write down these 2 charts. I'll wait for you. We're back. For those of you who are in my class and have this as a copy in your notes, congratulations, you don't have to write it, but let us follow along. Okay, here we go. So when I go from 10 to the third, which I know is 10 times 10 times 10, which is 1,000, and to 10 to the second, which I know is 10 times 10, which is 100. The relationship between these 2 numbers is just dividing by 10. And if I know that 10 to the first power is just 10, then to get from 100 to 10, I just divide 100 by 10. This is extremely important because what this table and both of these tables are showing us is the relationship between exponents and what it means when we scale the exponent up and when we scale the exponent down. So really, since math is all about patterns, we see that 1,000 to 100, 100 to 10, these are both dividing by 10. So we can guess, and correctly so, that 10 to the 0 can be found by taking my answer for 10 to the first and dividing it by 10. And 10 divided by 10 is the number 1. That's it. Excellent. Now the interesting part comes with what the heck happens when they go negative. And that's why patterns are so important. I take 1 and I divide it by 10. And of course, I can get 0.1. But really, to reinforce what happens, I am going to show you that it becomes a fraction. I have taken 1 and divided it by 10. Awesome. So since patterns continue, I take the answer of 10 to the negative 1, I divide that by 10 to get 10 to the negative second power, which is actually 1 divided by 10 to the second. And here's where you might start feeling uncomfortable because your understanding is lighting up all over your brain. When I have a negative exponent, it's gone down to the bottom. When I have a negative exponent, it's gone down to the denominator. That's what I meant by bottom, was the denominator. Insert Arnold Schwarzenegger joke. So for 10 to the negative third power, if you're screaming at your screen and you've already said I'm dividing by 10, so I know that it's 1 over 10 to the third power, that's because you're smart and a genius, mathematical genius. So yes, negative exponents are just changing location. That's it. If it's in the numerator, it goes into the denominator. And this is important because later you'll see stuff that happens in the denominator that's negative exponent, and that of course moves into the numerator. We'll talk about that more when we get there. So for the next part, for the power for exponential forms and standard forms, for the number 2 as the base, I'm going to let you guys fill that one out on your own. It's not on the video. Don't rewind or fast forward to try to find it. It's not there. But the seeds for doing the exact same table as the tens is right there. Go ahead and finish it out on your own. Pause the video. I'll be here when you get back. That's right. So for negative exponents, there are 2 basic rules. Negative exponents are just changing location. Like 10 to the third is equal to 1 over 10 to the third power. And any number raised to the 0 power equals 1. Let's take a look at some examples. Negative 12 to the 0 power. Uno. 7/15 to the 0 power. Uno. Just 1. Pi to the 0 power. Wow, pi is a complicated number, but no matter how complicated it is, pi to the 0, 1. Literally anything to the 0 power equals 1. Well, maybe not like, Lego Batman, but, that's because he has 9 abs. Has an extra ab in the middle. But really, any number that you can write mathematically to the 0 power is equal to 1. Skadoosh. negative exponents, 2 rules. So a couple of these I'm going to actually work out with you, but 3 of these I will not. It's kind of like, magical Christmas land. But go ahead and pause the video if you think or you're confident that you can do these on your own without my help. Okay, so if you waited and you're like, help me, help me, help me, let's go through A. All right, boom. A, I just changed the location, so it becomes 1 divided by 6 to the 3rd power. Now this is enough, but if you wanted to multiply it all the way out, it'd be 1 over 216. Excuse me. So now I'm going to take a look at example D. So if I'm rewriting example D, it's that the opposite of A becomes B to the negative 8th power. All right, pretty simple. Let's take a look at E. Now, both of these exponents are negative, but remember that exponents just mean changing a location. So really, the x is in the numerator, so it should go to the denominator, and the y is the denominator, so it should go to the numerator. So if you're screaming at your screen, you say it's y to the 3rd divided by x squared, you are correct. Mathematical genius. Okay, go ahead and pause the video and see if you can do B, C, and F on your own. I'll be back when you are done. And we're back. I hope you wrote down the work because it's not on this video. If you're in my class, that's what I'm grading, by the way, the work. Okay, again, there's not going to be anything in here to help you guys out at all. I'm not going to show you any answers for any of these problems, but I did want to point out something here. Number 26, which hey, if you're at home and you're like, where does that come from? It's because I got this example from the textbook that I use, but fair use and all that. 4 to the negative 4th times 4 squared. So to get their answer, I have 4 to the negative 4. So I'm multiplying exponents, so I add. So negative 4 plus 2 is 4 to the negative 2nd power. Change location. All right. 1 over 16. Sweet. When there is no exponent, the exponent is 1. Negative 5 times 1 is exactly. All right, go ahead and pause the video, G, H, I, and J on your own. I'll be back when you're done. Make sure you've shown the work for all of those problems. Write that summary answering the essential question, and make sure your table of contents is updated. And until next time, keep doing the math.